Okay, then we come to our next speaker, who has interrupted his holidays just to come here. So welcome, Markus, for this effort to be part of this event. It's great to have you here. It's on smart switches in AUTOSAR and the AUTOSAR ecosystem. So welcome, Markus, and here you go.
Thank you much. Thank you much, Kirsten, and thank you very much for the opportunity to speak about the importance of switch software today. Yeah, my talk is titled Smart Switches in AUTOSAR Ecosystems, and I structured it in 4 pieces. First of all, I'd like to talk about software and hardware architectures in more general, to get aligned here. Then I'd like to talk about automotive switches in AUTOSAR, especially about the limits. Also, Christian Herber is right, there are some limits already with AUTOSAR. I'd like to poke into that. Then I'd like to come to my main topic, the smart switches, and share my idea how we can deal with smart switches in AUTOSAR. And then in the end, I'd like to wrap up and give an outlook. So first of all, a little bit of history. How did we introduce Ethernet into the vehicle? It started, I think, at most of the OEMs, it started with isolated point-to-point networks. So these gray boxes are in the end ECUs, and they have a single link connected to some sensor or to a diagnostic tester, for example. And we just introduced this to have the increased bandwidth in place. But then to scale the networks and to introduce more nodes on the Ethernet, of course, we had to introduce switches. And this is a logical view, of course. You do not find switches like this in a network. The switches are typically contained in ECU. But I just wanted to show a little bit the history and also the how it developed over time. So, of course, we started with a simple network with one single switch that provided the connectivity to the attached nodes. And then we moved further to a domain-based architecture, as we have it more or less in most of the vehicles today, maybe with this aspect of a satellite. But we've already formed with this architecture in-vehicle backbone using Ethernet. But then the next step is we want to scale this further, and we want to move into zonal architectures, mainly to tackle the complexity of the today's wiring harness. And what you obviously can see here is that we need more switches in the vehicle to display such an architecture. And there's also one thing that is very important for me already, that this brings into a new way of thinking. Now we have the Ethernet as a shared medium, and we use it cross-domain. So the traditional domains like powertrain, chassis, body, multimedia, they all share the same network. And this is a kind of a mindset change that we have to take care about also in the organizations and at the OEMs and on the whole industry. But then, last but not least, when we are moving towards safety critical applications, we may also need to introduce redundancy. This will require even more features from the Ethernet networks, especially from the TSN world. I will not poke into details into that. But what we can see here is we are getting more complex, we have more switches, and we have much more features that we need to display in our networks. Okay, so I think for everyone it's obvious. We have a change now, or we are transiting here from the sheer demand of bandwidth to a reliable and secure network in vehicle backbone. That's one thing. And we have to tackle flexible and dynamic service-oriented communication in parallel with with control and streaming traffic that has really stringent TSN requirements, and this all comes together on the same Ethernet networks. So switches are essential for those networks. They enable communication, they control the network access, the latency, the bandwidth, and they play an important role to deploy the foundation of many applications like that we need, for example, the time synchronization and network reliability and security. But still, as I said, the number of switches is increasing, and we have increasing feature set, and these features, they want to be configured. They want to be designed in this network, and we have an increasing configuration and qualification effort that we need to cover somehow. So there are a couple of questions left open. How does the actual software and hardware architecture look like with those switches? Which software features are necessary on the switch itself? A little bit of spoiler. How do we ensure the overall configuration consistency? And last but not least, if we have software dealing with the switches, how do we update them? So I'd like to give you a small insight how the hardware looks like for a switch today, or switch ECU. So the dashed box is the ECU system, and you can break it down into an MCU part and the external switch part. Today I will only focus on external switch devices. And if we have such an ECU, then in a, I would say, traditional way, we have an AUTOSAR running on the MCU side on one of the cores, and this is then configuring the switch as an external device using management interfaces like the MDIO or SPI, or in some cases even via Ethernet with some proprietary protocols. But when we are using such an architecture, if we have a look at specific use cases, for example, for the time synchronization, then we already need to confess, this does not scale. If you have many ports and the MCU side needs to manage for the time synchronization each and every port and calculate the residence time compensation, for example, you create a dramatic CPU load on the MCU side. For other use cases, this MCU-based management is not feasible at all. For example, firewalling. You cannot drop each and every packet to the MCU via in such an architecture to make an inspection in software. This simply doesn't work out. So we have to think about how can we get to another architecture, and this is where the smart switches come to play. So what's the difference between this picture and the last picture? Well, the difference is that the devices that we see in the market today often come along with an own CPU directly hosted on the switch itself. So you have an own runtime environment where you can execute software, and typically those devices come along with an external flash. So you have to some extent the possibility to have an independent operation of the switch software, independent from the MCU. And those switches can be seen as smart if we get to a smart software architecture, and they can take over significant parts by offloading networking parts from the MCU to the switch. And even other interesting use cases come to play if you think about such an architecture. But how did we treat those devices that already exist in the market? There were two approaches which are not optimal. The first approach was we downgraded the switch. We just switched off the CPU subsystem of the switch so that we had this traditional AUTOSAR approach, meaning we managed the switch from the AUTOSAR side, so we could not use the resources that we have on those switch devices. This is definitely not a good approach to deal with those devices. The other approach is that we remove the switch driver on the MCU side and execute some proprietary firmware on the switch itself. But this has also a big drawback. In this case, the switch and the configuration of the switch is completely decoupled from the AUTOSAR configuration and update workflow. And the MCU is not switch aware anymore. So the MCU is not aware that there is a switch in the link in between. So, and this leaves a couple of questions open. How do we configure this subsystem of the MCU, which is the switch, consistently? Because the knowledge of the configuration exists only on the OEM side, on the vehicle scope. And today we are using AUTOSAR formats to provide the configuration. So how do we configure a switch in such a scenario? And then there are some other use cases like the UDS diagnostics or some further protocols that we may want to use on the switch already, but the existing firmwares do not provide this. If we look on a high flight altitude on this, what do we have in our hands with such a system? We have the MCU side, which has the CPU, which can run some software. Typically in those ECUs that we have today, we are running an AUTOSAR-based software. And on the switch itself, we have an own integrated CPU that could run our own software too. And the vision is now we want to distribute this in a proper way between the MCU and the switch. And which features are we actually expecting that are supported on the switch side itself? Well, we want to have a quick and independent startup of the switch, independent from the MCU. We want that the switch configures itself on startup quickly, independently from the MCU, so the switch does not need to wait for the MCU init phase. We want to offload the time synchronization. As I said, it's not scaling to do this. On the MCU side, we want to offload the PTP processing on the switch CPU itself. Then we want to have a clear understanding how we do a software and configuration update of this switch software, which is somehow behind the MCU from a diagnostics point of view. Same applies for the UDS diagnostics itself. And then we have further technologies that we want to have supported on the switch, like network management or further AVB and TSN features. And last but not least, there are already features come into play that we did not consider yet in the MCU-based approach, like firewalling or even some OEM-specific use cases like a variant provisioning, which could be really nicely handled on such a switch device. And in the close future, we already discussed in this event about MACsec. We also need some support on the switches itself for the MACsec handling. So, and how could such a software distribution look like between the MCU and the switch subsystem? What kind of software do we actually need, and which pieces are meaningful to be offloaded? If we assume we have an AUTOSAR basic software running on the CPU side of the MCU, then what do we need? We actually need something to schedule the software. We need some OS on the switch. We need some hardware abstraction, some drivers layer to have a uniform access to the hardware. And then if you have the vision of such a switch subsystem, then you want to have some diagnostics, as I said, network management, and security features running on the switch itself, just from a functional decomposition point of view. If we try to map this to something that already exists, then you get really close as a starting point from a minimal configuration to something that you could use even from an AUTOSAR architecture. So AUTOSAR today also provides you a clearly defined drivers layer, the Ethernet interface as an abstraction of the hardware, and providing a uniform Ethernet access. The advantage of using AUTOSAR here is that we have today already a configuration workflow and tooling in place, which is identical to what we are using on the AUTOSAR stack attached to this switch running on the MCU. In this small example now, I depicted how it would look like if we just offload the PTP handling to the switch itself. The PTP handling is done in the so-called Ethernet TSUN module in AUTOSAR, which carries automotive-specific extensions, which are going beyond the scope of the 802.1 AS. If we move this a little bit further, it just depends on the resources that we have on the switch, what you could do on such a device. So with an AUTOSAR switch-aware solution, we could even add further production-approved software that is already available from the AUTOSAR ecosystem to the switch itself. For example, the network management or the diagnostics is a valid point to move pieces of this to the switch to offload it on one hand from the MCU, and on the other hand to provide a more optimal architecture to execute this piece of software. In the end, we increase the overall system performance, and we can also shorten the time to market because we have already qualified software available that we can port on those devices. I'm already there to wrap up a bit. So there are challenges to overcome here. First of all, the software executed on the switch today is limited by the available hardware resources. Yeah? Today, I would say you cannot put a full-fledged AUTOSAR stack yet on a switch. So it's really limited to specific use cases. So on one hand, this is a hardware topic. Yeah? Especially use cases like firewall, intrusion detection, they will require significant resources. And also in the future, for example, for MACsec handling, you will need a possibility to use, to have a secure key storage available on the switches itself. But the more important thing for me is the mindset topic that I said very in the beginning of my talk. The switches are complex subsystems rather than simple peripherals anymore. Yeah? So those switches need to be taken into account in the network design phase. That means those switches, they will require own MAC addresses, IP addresses, and even diagnostics addresses. So we can make use of those smart switches in our future networks. And the software share and the feature set on the switches will play an important role in future ECU projects to be considered by the ECU component responsible. Yeah? There is always someone taking care about the box, and the switch is a significant piece of this box, and this needs to be reflected. Maybe also in organization structures. Last but not least, transport format, workflow, and tooling needs to be discussed. I'm completely on the same page with Mr. Herber. AUTOSAR is not a best-in-class way to define a switch configuration, yeah? And it's static. But this is also not the scope of AUTOSAR. The scope of AUTOSAR is to configure a complete ECU, or in this case, the complete runtime environment. And why not complement AUTOSAR even with other formats? At least I'm very open to discuss workflow and transport formats, and I'd like to get started with this discussion. Okay, my last slide. So I'm completely sure that the software share on the switches will increase, and the integrated software architecture is needed to meet the time to market, and AUTOSAR, to my opinion, may be a valid solution. And as a next step, anyways, we need to move on with functional safety concepts that will be required for automotive driving and introduction of MACSEC. So we need a solid foundation to move on. And even with this said, I would like to give you my vision, and it's not just a vague one. I would say we are already heading towards a switch as a fully independent single chip device. With this said, I'm done with my presentation, and I'm ready for your questions.
Okay, thank you very much. I have a question. If now vendors start to make their switches smarter, does that pose any interoperability concerns then? Depending on what you actually have on the switch and what you have somewhere else, maybe.
Interoperability between which parties?
Whatever you have. I mean, first of all, between communication links. Is there any? Do you see any chance that this requires some sort of standardization, that it's done similarly between different devices and different vendors?
Yeah. I would say it even the other way around. If today, if we are using different implementations which are not standardized in AUTOSAR, then you may today already have the issue that you have 1588, you have the 802.1AS, and you have the 802.1AS with AUTOSAR extensions already in the networks. We have this issue today already. I think we can even improve this by using standardized software on the switches.
Okay, and the standardized software?
AUTOSAR software.
Okay, AUTOSAR software. Max, did you have a question on this?
I did indeed.
Okay.
Because when we were trying to get IP into AUTOSAR, there was already a description in FIBEX. Yeah. And ARXML basically stole the FIBEX elements and included them into ARXML. Yeah. Not an elegant solution, maybe. Yeah. But it worked at the time, and I think it's still active. Is that maybe even for a static configuration, is there an option that we do ARXML and Yang elements, sort of like we included the FIBEX elements? Can we also include Yang elements into ARXML?
I mean, there were discussions to have such a blob of a configuration blob to be carried in the AUTOSAR XML. This is somehow what you are saying. I mean, I know these discussions, I'm open for that, but I think they did not lead to the end. What we need right now is a discussion which is the proper format for those very specific switch use cases. I mean, one use case is, for example, the TCAM configuration. It's completely unhandled in AUTOSAR, and we have a very big need to change this. Maybe Yang can also speed up this and maybe later on incorporate this then and steal it again from Yang into the AUTOSAR XML. Maybe this is a path, I don't know. We have always to separate between the compile time configuration and the runtime configuration. This is, of course, something completely different. But we need a formal description. And why not using AUTOSAR XML as a foundation, as a basis configuration, and let's say the specific fancy features as an add-on within separate format. Why not?
Thanks. Mm-hmm. We don't have any online questions, sorry.
Okay, we have a question, a live question though, from Stephanie. Yeah.
Hi, so thank you for the presentation. I have more practical questions to your picture that you show about the distribution. So I understood that actually you are segmenting the communication stack to offload it on the switch. So what would be left within the microcontroller from the communication stack?
Maybe then this was a little bit misleading. I wouldn't offload the complete communication stack. I would integrate a communication stack on the switch itself as well, so that the switch can have independent communication besides the MCU. So for example, if you want the switch communicate via some IP, for example, the switch itself would need a TCP IP stack to communicate as an own network node in the network. But what we would offload here is rather networking features, like as I said, the PTP handling, yeah? The residence time compensation. This piece of the time synchronization would be offloaded to the switch, so that the MCU, in the end, is then an end node from a PTP side only. So the switch handling part is offloaded to the switch.
Okay, so does it mean also when, I mean, this picture is also very well represented. When we will want to use a switch with a classic platform or whatever AUTOSAR, does it mean that we will have a vector stack for the microcontroller and a vector stack for the switch?
As a stack vendor, I would like to say yes, yeah. But first of all, I just wanted to say that it makes sense to use standardized software on the switch itself, yeah. Of course, we as a stack vendor, we want to provide a holistic solution that even spreads over those subsystems. But this is not what I want to state. It does not mandate this. If there is an AUTOSAR stack running on the MCU side from another vendor, we would even be happy to provide an AUTOSAR stack for the switch itself.
Okay, thank you.
Yeah.
Okay, and we have an online question.
Yeah, we actually have one question, and I would read out a statement that was posted in the chat just to make this a real hybrid event. So Harry Palmer asks, are you able to say whose switches you have done your development with?
I know why Harry is asking this.
Does that answer the question in itself?
I do not say more than that on the stage.
Okay. And then I'm going to be reading 2 cents from Oliver Crichton, who says, not sure if we want to make ARXML the universal yet static all-containing format. Let's keep the network configuration more modular and dynamic. You want to comment on that? It's obviously not a question.
Yeah. How to say, yeah. Well, we have seen in Christian Herber's presentation that the young models are very diverse, yeah? And in the end, we need a discussion. What is the sweet spot? Yeah, how to combine those formats. I know AUTOSAR is not the best-in-class configuration format for the switches, but it aims to configure the complete ECU. Maybe we need a companion format. Could be the case. Why not?
Okay, thanks. There is quite a lag on the video. I noticed that's why maybe some of these come in a little late.
Ah, okay.
Because people don't notice that you're done. You're still talking online then.
Oh, okay. Well, that's good to have some experience here. Well, then, thank you, Markus, for your presentation once more.